Residuals. In this video, you'll learn how to plot and calculate residuals for a data set and use the information to judge whether a linear model is a good fit. Let's start by looking at residuals. A residual is the difference between the actual y value and the predicted y value from a linear model. Residuals help us assess how well a linear model fits the data. The formula that we'll use to find the residual is the actual y value, and then we'll subtract our predicted y value. So let's look at an example. The table below shows the data of the number of oranges and their weight. The line of best fit is y equals 0.211x plus 0.3775. What is the residual for the weight of 4 oranges? So we'll start with our formula where we'll take the actual y value and subtract the predicted y value. We can find our actual y value, which is considered the weight, by looking at the table. So when there were 4 oranges, the weight was exactly 1.162. So we'll put this in our formula for the actual y value. To find the predicted y value, we'll take the equation they gave us for the line of best fit, and we'll replace x with 4 since we want to know the weight of 4 oranges. Multiplying 0.211 times 4 gives us 0.844. And adding that to the 0.3775 gives us a total of 1.2215. So now we can put this in our formula since we know that was the predicted y value. And now we'll subtract these two values. This gives us a residual of negative 0.0595. So we know how to find the residual, but now let's look to see how we can interpret them. Let's look at interpreting residuals. Smaller residuals represent a better fit for that line. A good linear model has residuals that are small and randomly scattered. If the residuals follow a clear pattern, then that tells us the data may not be best modeled by a linear function. So let's look at some examples and interpret the residuals. Han creates a scatter plot that displays a relationship between the number of items sold, X, and the total revenue, Y, in dollars. Han creates a line of best fit and finds that the residual for the point 13 and 930 is negative 40. We'll interpret the meaning of negative 40 in the context of this problem. Let's start by looking at the point they gave us. So we have 13 and 930. Since X represents the number of items sold and Y represents the total revenue, then this tells us that when 13 items were sold, the total revenue was $930. Now let's look at the residual of negative 40. This says that our actual value was negative 40 units off. So the predicted value must have been $970. Here's one last practice set. We'll use the line of best fit for a data set, which is y equals 1.1x plus 3.4, and we'll find the residual for each coordinate pair below. We'll start with 5 and 8.8. Our formula is our actual y value minus our predicted y value. We can see that our actual y value was the 8.8 in this set. To find the predicted y value, we'll take the line that they gave us, and we'll replace x with 5 since that's the number given in our coordinate. 1.1 times 5 gives us 5.5, and when we add that to the 3.4 we get a total of 8.9. So now we know our predicted y value. So we'll subtract this from our actual y value, which gives us a residual of negative 0.1. Now let's look at our next coordinate. So we'll take our formula that we used for the residual, and our actual y value is 5.95. To find the predicted y value, we'll take our equation again, and this time we'll replace x with 2.5. Multiplying that by 1.1 gives us 2.75. When we add that to the 3.4, we get a total of 6.15. So we'll put this in our formula so we can subtract now. Our residual for this one is negative 0.2. Now let's look at our last coordinate. We'll take our formula again, and our actual y value is 3.72. To find the predicted y, we'll take our equation again and replace x with 0. This gives us 0.3.4, or just 3.4. So we'll subtract this in our formula now. This gives us a residual of 0.32. Now we can see all of our residuals for the 3 points, And we see that they're all pretty small, so this is a pretty good line of best fit. Let's recap what we've learned. When fitting a linear model to data, it can be useful to look at residuals. Residuals are the difference between the actual y value and the predicted y value. A line that has smaller residuals is more likely to produce estimates that are close to the actual value.